Greetings, geometry students. Today we are continuing on with a little bit of further discussion on logic and reasoning by looking at some different types of statements that are referred to as the negations. Please copy down the title as well as the objective and your essential question. Our objective for the day is going to be to discover the meanings of negations and apply them to provided conjectures. Our language objective is going to be the student will demonstrate the ability to transform provided conditional statements into their negations and then weigh the truth of those new statements. That will make a little bit more sense here in a little while. And your essential question for the day will be, can I write the negations of a statement and weigh their truths? Now the notes today are a little bit wordy. This is more information and theory than anything else. Okay, so press pause anytime you need more time to get something copied down and then hit play when you're ready to move forward. So let's get started. Okay, now a little brief review. We have discussed conditional statements and their structure. Okay, we looked at our statements the other day, the conditional format. If P, then Q. Okay, we talked about P being the hypothesis of a conditional statement and Q being the conclusion. So P is some type of an observation or a fact that we have going on, and then Q is our prediction or a conclusion of what can be determined based upon that observation. Now, almost all of our theorems are written in this format. Okay, for example, I'll pick on one that you're already familiar with, and we'll be going over this year as well, the Pythagorean theorem. Okay, Pythagorean theorem, everybody knows, basically boils down to a squared plus b squared equals c squared. But if you think back to all the information, okay, it started off saying if you have a right triangle, then a squared plus b squared equals c squared. Okay, so if you have a right triangle, that was the observation, the pattern. All right triangles follow this following rule. Then, here comes the conclusion, a squared plus b squared equals c squared. Okay, so the strongest of our theorems are written in this format. Remember, theorem is a rule that requires mathematical proof. It is not common sense, has to be kind of laid out for us in order for us to understand it. Okay, what we're going to do is we're going to take our conditional statements that we have and we're going to rearrange them in several different ways and then investigate the truth of these new statements from other perspectives. Okay. Now please keep in mind conditional statements are conjectures, and conjectures are supposed to be true. Okay, we talked about having counterexamples. Counterexamples are situations that can disprove a conjecture. Okay, so hopefully our conditional statements do not have any counterexamples, and we won't have to worry about that. Our conjectures will be absolutely true. Okay, so to introduce our negations, we're going to work with a conditional statement just to kind of get ourselves started. And our conditional statement is going to be, if it is noon, then it is daytime. I've been using this statement for a lot of years, and we've had a lot of arguments over this statement over the years. But let's just keep it simple. Okay, we're not trying to get real technical here. We are simply saying if it is noon, which is 12 in the afternoon, the 1 hour that is in between 11 o'clock in the morning and 1 o'clock in the afternoon, and daytime simply refers to the time of the day where the sun is exposed to our side of the planet. So we're not arguing about whether it's cloudy or whether the sun's actually out or shining that day. We're simply saying if it is 12 p.m., okay, right in the middle of the day, then it is daytime. Okay, that is a complete factual statement, so we have a good solid conjecture. Okay, now the first of our negations is what is referred to as a converse. Okay, so we got a new term there, and a converse will take a conditional statement and switch the position of the hypothesis and the conclusion. Okay. Now it's important to remember on hypothesis and conclusion, if and then are not actually the hypothesis and the conclusion. Those are just kind of trigger words that we can watch for that will introduce where the hypothesis and the conclusion may be in a conditional statement. Okay, so if we're starting off with our conditional statement, if it is noon, then it is daytime. And then we were interested in looking at the converse of this statement. Okay, well, if it is noon, that is the observation. We can look at a clock and see that it is 12 p.m. So that's our observation, then it is noon. The conclusion would be then it is daytime. So you can see you got your hypothesis, it is noon, which is triggered by the word if, and it is daytime is your conclusion. It's associating with the word then. The converse is going to take your hypothesis and your conclusion, and it's going to reverse their positioning. Okay, so the converse would read, if it is daytime, then it is noon. Now please notice the if and the then did not go anywhere. It is simply the information that was associated with if and then. If and then are not hypothesis and conclusion. Those are just prepositions that help fill the sentence and hold it all together. Okay, so you would not move the if and the then along with the hypothesis and the conclusion. This is a converse. Now, what you have to do when you look at a converse is we have changed what the statement said. You have to evaluate the truth of this new statement on a case-by-case basis. Just because you start off with an absolutely true conjecture does not mean that you're going to end up with an absolutely true converse. That's not the way it always works. Okay, so you have to actually stop and think about it. Well, let's have a look. Okay, what is the truth? Okay, our converse can be always true, meaning we cannot come up with any counterexamples whatsoever. Our converse can be sometimes true, meaning maybe there are some counterexamples, but they don't hold up all the time. And then we also have the possibility that it is never true. The statement's just out and out a lie. Okay, so I've got a little redundancy there in my notes. Ignore that statement. Okay, so in this particular case, for this particular statement and its converse, if it is daytime, then it is noon. Okay, well, chances are by the time we're talking about this lesson in class, we will be able to look out the window and see that we have daytime. But unless we happen to be looking at that particular moment where the clock is exactly at 12 o'clock, then we would not be able to say that it is noon. Okay, so there are situations where, yes, the converse could be true, but a lot of situations where the converse would not be true, and that would leave us with basically having to state that our converse in this case is sometimes true. Okay, now another type of a negation is what is called an inverse. And what an inverse does is it takes our original conditional statement and it negates both the hypothesis and the conclusion. Now, if you're not familiar with this term negate, well, it's very similar to the word in mathematics, negative. And of course, the negative of something typically means basically its opposite meaning, +5, -5, and so on. Okay, so negate means to basically reverse the meaning of the hypothesis and the conclusion. So let's take a look at what that would do. Our conditional statement, you don't have to copy it down again, you've already got it. But our conditional statement is, if it is noon, then it is daytime. Now the inverse is going to negate the information. Now don't get too terribly carried away here, okay? We're not going to change the time of day, okay? We're not trying to come up with anything, really creative here. We're not going to say, oh, okay, instead of saying it is noon, now we're going to say it's 11 o'clock or 1:52 in the afternoon or anything. We just simply want to reverse the meaning. Okay, so what is the opposite meaning or the opposite statement of it is noon? Okay, well, to basically counteract that statement, we would simply say if it is not noon. Okay, again, not trying to change times, not trying to get really cutesy or creative, just trying to reverse the meaning here. Okay, and that would leave us with the conclusion then, instead of it is daytime, okay, we're looking at it is not daytime. Okay, so that would be an inverse. If it is not noon, then it is not daytime. Okay, and again, the inverse, even though we started off with a completely true conjecture, inverse can be, once again, always true or sometimes true or never true. And you have to measure that in a case-by-case basis. Okay, so let's have a look at this inverse and decide, is this always true, sometimes true, or never true? Okay, if it is not noon, okay, chances are when we're talking about this in class, we're going to be sitting there looking at it going, okay, it is currently not noon, unless it happens to be that perfect time where it is exactly 12 o'clock. Okay, so if it is not noon, then it makes the statement, then it will not be daytime. It is not daytime. Well, we'll probably be able to look right out the window and determine that that is not the truth. We have the sun out. Okay, there's light on this side of the planet. Okay, so we can't say that it is not daytime, but there is that possibility that we might look at it and say, you know what, it is not noon. Like right now, I'm recording this video, it's 9:34 p.m. It is definitely not noon. Okay, so when I look out my window right now, it is definitely not daytime. So there are cases like y'all sitting in class when we're discussing this video. Okay, yeah, there will be truth to that. Truth to it, some truth, possibility. Okay, and I'm looking at it right now and saying, okay, it's absolute truth from where I sit, but that kind of puts us in a spot where we can see some truth and we can see some lie to it, so it's got to be, in this case, once again, sometimes true. The final form of a negation is what's called a contrapositive. Okay. Now, contrapositive, while it sounds like a really complicated term, it actually has a fairly simple meaning. Contrapositive takes the conditional statement, negates the information, and switches the positioning of the hypothesis and the conclusion. Now, if you listened to me say that and you said, wait a minute, Mr. Hill, a few seconds ago you said it was going to be a really simple meaning, and then that sentence did not sound really very simple at all. Well, it's actually not that bad. Okay, we have already talked about a converse and what it does, and an inverse and what it does. A contrapositive does the inverse and the converse at the same time. So if you know what the two different negations are that we started off with, converse, inverse, if you know how they work, do them both at the same time to the same conditional statement, and you have a contrapositive. Okay, so once again, here's our conditional statement, and you don't have to copy it down again. You've already got it. If it is noon, then it is daytime. So let's take a look at the contrapositive. Okay, now the contrapositive is going to do the converse. So we're going to switch our hypothesis and our conclusion. It is noon and it is daytime are going to switch places. And it's also going to do the inverse of them. Okay, so once again, instead of it is daytime, we're going to have to say it is not daytime. And to finish off the statement, we will have, instead of it is noon, we will have then it is not noon. That is your contrapositive. If it is not daytime, then it is not noon. Okay. Now, this one is a little less judgmental as far as figuring out the truth of the statement. If you started off with a strong conditional statement that did not have counterexamples or non-examples that could disprove it, if you started off with a conditional statement that was true, then the contrapositive ought to be true as well. It's not a bad idea to go ahead and read your contrapositive and make sure if it is not daytime, then it is not noon. Right now, 9:37 p.m., I look out my windows. It is nighttime, so it is not daytime as I read this screen, and I look at the clock and go, you know what, it is definitely not noon. Okay, so it's not possible to be nighttime and noon at the same time. Okay, so we have a contrapositive that is absolutely, positively true. There is no counterexample to fight against this one. Now here's the thing, these guys, the negations, when we work with our strongest theorems, such as the Pythagorean theorem, what we're going to discover is that the theorem is true. Obviously, it's not a good rule if it doesn't actually hold true, but additionally, the converses and inverses and contrapositives of these rules are also true, and that is kind of a powerful tool in mathematics that allows us to take one rule and use it 4 different ways in order to accomplish 4 different things. And that greatly kind of uncomplicates a lot of things in math, because we don't have 4 different rules for 4 different situations. We have one all-encompassing rule that has negations that go with it, and it's those negations that allow us to use the rules in different ways. Okay, I think you've probably got the idea here, but I'm going to run you through an example here real quick. Let's look at a new conditional statement. If an angle measures 90 degrees, then it is a right angle. Please copy this down. We're not finished yet. Okay, if an angle measures 90 degrees, then it is a right angle. Let's evaluate the truth of that real quick. Okay, if an angle measures 90 degrees, then it is a right angle. Yeah, absolutely. That is the definition of a right angle. That's what it has to have, is a 90-degree measurement. So we're looking at an absolutely factual statement here. Okay, let's take a look at the converse of that statement. Now remember what a converse does? Takes your hypothesis and your conclusion, and it switches their positioning within the statement. Do not transfer if and then around in the statement with it, just the information that associated with if and then. So instead of if an angle measures 90 degrees, we're going to say if an angle is a right angle. Instead of saying then it is a right angle, we say then it measures 90 degrees. Okay, so let's look at this guy now. If an angle is a right angle, then it measures 90 degrees. Is this a truthful statement? Absolutely. Okay, right angle and 90 degrees are basically synonyms. They carry the same meaning, so it really didn't matter the hypothesis and the conclusion being switched that way. So we're looking at a converse this time that is always true. Okay, how about the inverse? Okay, we started off with a statement that said, I've forgotten the statement. I'm going to switch back here real quick. If an angle is a right angle, then it measures 90 degrees. Okay, well, the inverse is going to negate that meaning. Okay, so, and again, don't get real creative. Don't start changing 90 degrees to a different measurement or anything like that. We're simply saying instead, yes, if it does measure 90 degrees, well, if you turn that around inside out, it's kind of like saying, all right, it does not measure 90 degrees. It can be any other measurement, just simply not 90. And if the angle does not measure 90 degrees, then it is not a right angle. Again, don't go in there and start changing vocabulary. Don't change right angles to acute angles or obtuse angles. Okay, don't do anything really creative. Just reverse the meaning. Okay, so let's have a look at that, the truth of it. If an angle does not measure 90 degrees, then it is not a right angle. And that is absolutely the truth. It must measure 90 degrees if it's going to be a right angle. So if it doesn't measure 90, it's not going to be a right angle. So our inverse as well is always true. Now we expect the contrapositive to be true because our conditional statement was very solid true. Okay, but let's go ahead and look at it anyway. Okay, now remember, a contrapositive is the inverse of the converse. So we're going to switch the hypothesis and conclusion, and we're going to negate the information. Okay, so a contrapositive would start off saying, if an angle is not a right angle, then it does not measure 90 degrees. Okay, so we'll stop and take a look at the truth of that. If an angle is not a right angle, then it does not measure 90 degrees. Well, as anticipated, that is absolutely the truth. If an angle is not a right angle, then it cannot measure 90 degrees. Okay, so there you see it. We started off with a very, very solid conditional statement, and then no matter which of the negations you look at, we end up with truthful statements over and over and over again. And again, that's part of the the magic of the English language is that there's a lot of different ways that the same information can be said without altering the meaning of what was said. And you just saw an example of that right there. 4 completely different sentences that all carried precision amounts of information on this definition. Okay, well, that's all we got right there. Okay, the negations and contrapositives. This is not a real strong topic in mathematics. It's not something we have to know tons and tons about. We just have to be aware of its existence. We have to know what the terms mean. Okay, so go ahead and write yourself a summary. Jot down any questions that you may have, and keep that essential question in mind at the end of the lesson, at the end of the worksheet. Can I write the negations of a statement and weigh those truths? I appreciate you finding time to get your notes taken care of, and I will see you in class.